All right, on this next example, we're going to go ahead and look at instantaneous velocity. Okay, so what is instantaneous velocity? Instantaneous velocity is the velocity at a second. Okay, in that instance, what is the velocity? And velocity is speed. We also know that velocity is the same as slope. So what it's saying is find the slope at 1 second, at one time. That's hard to do, as we talked about earlier in this lesson, because typically you guys find slope using 2 points. So whenever I'm asking you guys for instantaneous velocity, I am asking you for the slope in an instant. So it's your slope at 1 point, which you all know from the earlier lessons is the slope of the tangent line. And I already alluded to this, but this is your derivative. Okay, so I'm actually going to show you guys how to find instantaneous velocity a different way, as opposed to like taking 2 points and finding the slope over and over again of the secant line to approximate the tangent line. Okay, so what we want to do is we want to find the instantaneous velocity at time t equals 1. Okay, so what we do is we use a limit. Okay, so a limit is what we use, and we look at it looks at the trends of how things are going. Okay, so our limit, we're going to take the function, and it's going to be s of 1 plus h minus s of 1 all over 1 plus h minus 1. Okay, so let's just talk about what this is. This is kind of our initial setup. Okay, so I am asking you guys to find the slope at 1 point. And our point is when s is 1. Okay, so here's our equation for slope. Okay, this 1 plus h is a new part. So what it is we are thinking to ourselves, okay, we want to find it at 1, but I only know how to find slope using 2 points. So I'm kind of making up this second point. So the way I make it, so I'm finding my slope at just a singular point, is I say take my limit and look at it as h approaches 0. I want h approaches 0. Because what if I put in 0 for h? I would be s of 1 minus s of 1. So I'd be at the same point. I would be at a singular point of 1. Okay, so anytime you guys are asked to find the instantaneous velocity, you make up 2 points. Your 1 point is whatever number you're coming at, and then you say 1 plus h. Okay, if I said it for t equals 5, you would have t equals 5, and you'd have t equals 5 plus h. And then what you do is you say, well, make that h approach 0. If h is 0, you're looking at it from 5 to 5, which is at that moment, at that one time. So here is our setup for instantaneous velocity. And once again, it's super important that you guys write down this setup, instantaneous. Okay, so now let's go ahead and actually figure out the instantaneous velocity. I'm going to do a little side work, okay, and then I'll come back and fill this out. So I first need to find s of 1 plus h. S of 1 plus h, plugging it into our equation here. So it'd be 2, and then I have 1 plus h squared. And then I would have 2, and remember you got to write 1 plus h squared twice, and we got to simplify it. So 2, and then I'd have 1 times 1 is 1, plus h, and then if I distribute this one, so I got h, and then I plus h, and then plus h squared. Okay, so I have 2, and then this is 1 plus 2h plus h squared. And then finally I would distribute my 2, so this would be 2 plus 4h plus 2h squared. Okay. Now from here, I would also find s of 1. Beauty is we found it in the previous example, but in case you forget, you just go ahead and plug it in. So it'd be 2, then I'd have 1 squared. 1 squared is 1, 1 times 2 is 2. So here's like my work. Now I'm going to go ahead and plug it into my limit. Okay, so my limit is equal to, got to still write the limit. We'll talk about how to handle that in a little bit. So limit as h approaches 0. S of 1 plus h simplifies to this, so I'd write that down. 2 plus 4h plus 2h squared minus s of 1, 2, all over And now look at what happens to my denominator. That actually simplifies. I'd have 1 plus h minus 1, so that'd be just h. One thing I want you guys to notice is your difference quotient. We covered this earlier in chapter 1, and we're going to simplify this. There's things that'll cancel, so the 2's will cancel out nicely. And then from here, you guys should see you can factor out an h or divide both by h, so we're going to do that. I am running out of room, so I'm just going to quickly take this to the next slide. Sorry. And I'm going to simplify. So we got my limit. So those cancel. I'm going to I'm going to factor out an h out of my numerator, you guys. Biggest thing is I still haven't done anything with that limit yet, so just keep tacking it along. That's super important to keep tacking it along. So I'm taking out an h, so we'd have 4 plus 2h all over h. The h's will cancel. And now I haven't done anything with my limit. I must still continue to write it. If you're watching this and you're in my U of M Calc class, it's important that you write limit. You continue to write limit each time until you actually plug in h equals 0. Okay? Otherwise, you will lose points on an exam. So now h approaches 0. What I can do is I'm taking that h and making it 0. So I would plug in 0 for h. So I would have 4 plus 2 times 0, which gives me 4. Notice I plugged in 0 for h. And once I did that, I stopped writing the limit, okay? And so my answer is 4. So my instantaneous velocity in that moment for that particle is 4. And then we need to talk about labels. We have y's over x's. So if we go back, once again, it's the same as before. My y values were meters, and my x's are my time in seconds. So it's 4 meters, don't forget to label, per second. So there's that. Some of you might be asking, why did you not plug in h equals 0 earlier? I would have, however, the denominator. Can I have 0 in my denominator? I cannot. So I had to simplify that difference quotient all the way in order to plug in h approaches 0. Okay. So in this instant on my graph, my tangent line has a slope of 4, but since we're talking about the velocity, my velocity is 4 meters per second.